Okay, so now let's talk about the Java API. Okay, and so related to this, so we are interested in the TCP/IP connection. Okay, so for the TCP/IP connection, yes, we have a couple of classes to be used. Okay, this is from the java.net package. Sorry. So fine. So from the java.net package, there are a couple of classes which at least we should know. Okay, fine. We are not going into all the details here. Fine, for the networking part, we are just looking at the API which will be necessary for us. Okay, fine. So in the java.net package, we have two classes. One of the class will be the, okay, we can look at the server socket class. Okay, and another class is the socket class. Fine. So the most commonly used constructor, okay, for server socket, right? Okay, so for server socket, one of the constructors to be used, okay, will be to take an integer for the port number. So creating a server socket, fine. So if you create a server socket, you are specifying a port number. Okay, so what would happen with this? Okay, so when you call the constructor of a server socket, right, you are asking the OS, I want to reserve this port number for me. Okay, just reserve this port number for me. So now this constructor can throw an exception in case the port is already in use or it's a privileged port and you don't have the right to it. Okay, so if you are not an administrative, we are not running it as an administrator, right? Or in case of Linux machine or Unix like machines, if you are not the root user, okay, in that case it will throw an exception for the privilege. Okay, which are the privileged port numbers? Right? Port
2123
1024 greater than or equal to 1024. Port numbers greater than or equal to 1024 are the privileged port numbers. So, sorry, I'm sorry, it's the other way around. Are the not privileged less than 1024? Okay, right. So port numbers less than 1024, they are the privileged ports. Fine. See, it's simple. Like in our, in our normal, when we use those landline and all those telephone usage also, if you look at it, 3-digit numbers, right? We have those 3-digit numbers which are actually the privileged numbers. Okay, fine, reserved for certain services, right? So if there are services, yes, we normally have those 3-digit numbers. So most of the time your services would be using these privileged port numbers. Okay, and they will be less than 1K. Oh, that's a digital 1K, and we have, so okay, so that way you can know, yes, this is what is a privileged port. Okay, so privileged port numbers are less than 1024. So calling a constructor for with privileged port numbers, then yes, you must be having the either be you must be an administrator. Okay, to use. So you find, so if you are not an administrator, yes, you can use port numbers greater than or equal to 1024 and above. Okay, fine. So server socket means, okay, so when you, as soon as you call the server socket, okay, it would reserve a port. Not only it reserves a port, but it starts listening right there itself. Okay, it starts listening for a connection right there itself. Okay, fine. So server socket, yes. So let me go through a sequence of what would normally be the case. So with this, what has happened? If someone has created on one machine, someone just called a constructor for server socket and specified a port number. That means he is ready and listening on a port number if this is successful. Okay, we understand when it will be successful and when it can fail, if it's already in use or it's a privilege and you don't have the privilege for that port number. Okay, fine. On the other hand, fine, we also have a class called socket. Okay, fine. We'll come back to the methods in server socket, but yes, we have a class called socket. Okay, whose constructor is used by a client. Okay, so client uses the constructor of socket where he can specify. So various constructors are available. One of them says, okay, you can specify a string for the host, okay, and an integer value for the port number. Okay, fine. So this can also throw an exception. Fine. So when you use this constructor, what will be done? It will acquire a local port number, whatever is available. So it needs a port number. So it will get some port number of its own. Okay, client gets allocated some port number, whatever is available, right? And then it will use this port number, local port number, to then make a connection to the port on the given host. Okay, so this is the targeted host and port number, right? So this is my destination, right? But before destination, you must have a source. Anyway, that source is not given to you in the constructor. You don't decide basically what is the local port number. For a client, port number is not decided by the client code. It is decided by the operating system who is allocating. So port numbers are resources. Okay, they are resources, fine. They are acquired by a server by using a specific port number. In case of a client, the port number is not decided by the client and what it is using, but it is decided by the OS who is allocating the next available port number. And the port numbers allocated, it will never allocate a privileged port number for the client. Okay. Fine. So it will allocate, and then yes, so for this to succeed, there must be someone listening on that host with that port number. So first thing, a server socket would have been created. If I'm just looking at only the Java code, right? So from the Java code point of view, yes, on the other machine, on that host, okay, on this particular host which the client is mentioning, there must have been some server socket which has been created with this specified port number. Okay, in that case, this is successful. But one thing what happens here, when you call a constructor, if this kind of a constructor of socket is successful, understand that there are two sockets getting created simultaneously. One socket is created through this constructor. The other socket is getting created on the host machine. Okay, the other socket is getting created on the host machine where the server socket is listening. So server socket, when it is listening for a connection, I said, okay, you just create it, it's listening for a connection. When it's listening for a connection, and if someone, as soon as someone connects, a socket gets created there. Okay, a socket would be getting created over there. Okay, fine. So on the server side, the socket which has been created, okay, if that server process wants to use that server program wants to use that socket, okay, he will opt in, and therefore I'll come back here, right? So we have method here, a useful method here. Okay, so okay, there are other methods, but fine. One of the methods which will be useful is a method to return a socket object. Name of the method is accept, no parameters. So now one more thing about the accept method here, right? Accept method is a blocking method. Right? So what will happen here is something like this. Someone creates a server socket, it has started listening for a connection. Fine. On this server socket, if someone calls accept method and there's no connection yet, Right? The accept method is blocked. It's just waiting for someone to connect. Okay, it's waiting for someone to connect. It won't proceed to the next statement. So you created a server socket, and then suppose you call the accept method immediately following it. Okay, then yes, it's waiting, waiting, and waiting for someone to connect. Till someone connects, it's just waiting only. It's not going to proceed further. Okay, of course, there is a timeout which you can have. Okay, we can specify a timeout. I would like to wait for someone to connect, but if I'm waiting for more than so much time, okay, then accept method should throw an exception for me. Okay, I don't want to be just blocked there forever. I cannot be blocked forever. So in case you decide that you don't want to be blocked forever, okay, fine, you can also use another method. Okay, public method returns void. There's a method called set so timeout, and it takes integer for the timeout value, which is I think in seconds. Yeah, timeout in seconds. Okay, and it is the timeout value which is in seconds. Okay. So you can do this, set the timeout for the accept method. Right? So this is a timeout which will be applicable to the accept method, which is actually a blocking method.
Timeout, whatever integer you are passing.
Yeah.
Would be seconds. So that
In seconds.
you have a date time method of calling that system dot milliseconds or something.
Okay, milliseconds is okay. That's a current time, but this is the interval. Okay, this is about an interval. Oh, my timeout is 10 seconds, something like that.
Internally, it will be calculating the 10 seconds.
This is 10 seconds, right?
Internally, it will be calculating.
Okay, you want to specify 10 seconds as your timeout, right? So you created first. What you might do is you'll say, okay, let me have a server socket, right? Equals new. Okay, and maybe you give port number 1024. Okay, and then you'll say, okay, ss.set so timeout, and you're giving 10 seconds. Okay, now you call ss.accept. Okay, and okay, of course, that would be returning a socket object. Okay, so if you call this, okay, so here the accept method, or no one is connecting for 10 seconds, this will throw a exception, and then only it will be able to proceed further. Fine. So accept is a blocking method, throws an exception after the timeout. If you don't give any, if you don't set, fine, it is equivalent to saying set socket timeout to, I think, 0 and a negative value -1. I think they work the same way. But by default, by default, I think the timeout, if it is set as 0, that means it's an infinite wait. Okay, 0 would mean wait infinitely. Yes. Okay, so it just keeps on blocking. It will only come out when someone connects. Okay, fine. So if you don't do this, yes, this is exactly going to wait till someone is connected. Okay.
Java shell I tried it.
Yeah.
So if I say 10, it immediately throws exception. But if I say 100, 1000, so should it be in milliseconds? Timeout.
Okay, timeout, could it be in milliseconds? Okay, just try that.
If I tried, I said 10, immediately it throws exception.
This one, accept.
But if I put 100, then it is waiting for some time and then throwing exception.
Okay.
So it should be in milliseconds.
I think this is in milliseconds then. Yeah. Okay, thank you. So this is milliseconds. Okay, so timeout you can specify in milliseconds. Okay, is it taking? Yeah. Okay. Also, you have a method to return the get SO timeout. You can know what is the current timeout setting. Right? But if you don't set the timeout, it's going to be infinite. Okay, so fine. So obtaining a socket on the server side is with the help of accept method. That's one thing. Okay. One more thing which is related to the accept method is suppose you actually you created a server socket, right? You did some other activity, okay, some time involving activity, okay, and during this time someone has made a connection. Okay, if someone has made a connection, yes, he is not going to get an error. A socket is getting created here within the premises of the server socket. So server socket, a socket object is created for him. Okay, it's available for use. It's only by calling the accept method that he will be able to use it. Okay, so he gets the socket from the server socket. Okay, right. But if there is no server socket, it has to still wait. If there's no, so in a server socket, there is a socket object as soon as a connection is done. Right? And that socket object can be called with fetched with the help of accept method. If no socket is available in the server socket, the accept method simply waits. And that's how we look at it. Okay. Right. So this is how a server would be using it. Okay. So for server, there are two steps to obtain a socket. First, create a server socket. Second step would be to use the accept method on the server socket. Okay. For client, let's see, for client. Oh, for client, what is the step for making a TCP/IP connection? Just call the constructor and you get a socket, right? The code would be saying, okay, for example, the code will be, okay, for client, how does a client get a socket? S is equal to new socket, and he'll just specify some as a string, he'll specify the IP address or whatever, right? Or a host name which can be resolved, okay, and specify a port number. Maybe, oh, there it is using 1024, or he uses 1024. Whatever on the same port on which the server socket was created. Okay, and so this port, right? We are trying to match the, so the client for this would be using this. So for client, it is one step to obtain a socket object. Okay, fine. Now once we have a socket object, okay, fine. So obtaining socket on both ends, right? Constructor for socket was here, but socket gets available for the client. So two sockets getting created simultaneously. That's one thing we have to understand. And this is a connect. These both of these sockets are connected sockets. Okay, fine. And what does a socket have? Okay, so what does a socket have? What does a phone have? A transmitter and a receiver. Okay, so what does a socket have? Output stream and input stream, right? So yes, we have these two methods. Method to return input stream, get input stream. Okay, we have also a method to obtain the get output stream. Okay, so we can use these methods to obtain the input stream and output stream, and on these objects you can start reading and writing. Okay, so once a connection is done, Okay, fine. So a connection is done with the help of the client calling the constructor of socket. Okay, so once it is done, fine, then both are connected. Okay, so then we have a input stream, output stream at both ends, because they both have a socket, and socket has input stream and output stream. Okay, okay, fine. So let's visualize it like this. Okay. So it's let's say we have okay. So this side, let's say we have a server, right? So you created a here a server socket object has been created. Okay, so where he is listening for on a port number. So he's saying, oh, I'm using port number 1024. Okay, so waiting for connection on 1024, and that's a server socket object. Okay, so this is a so there is a server socket object which has been created, and on the other side, okay, let's say this is a client. So client says, oh, I would like to connect to this. So whatever is the IP address here, fine, this is what should be known to the client here. Okay, so client says, I want to create a socket object. Okay, and I want to create a socket object on that port number 1024. So what happens for him is, yes, as soon as he makes a connection, if this is successful, what is happening is this server socket object is used for creating a socket with the help of accept method. So with the help of accept method, he will get a socket object created. Okay, fine. But this socket is not created alone. It has been created with the help of a socket object over here. So we have two socket objects. Fine. So this is the socket for the client. Okay, socket for the client. This is the socket for the server. Okay, it's not server socket, it is the socket for the server, but both are socket objects. Fine, one for the client, other for the server. Okay, and they both have an input stream and output stream, and the relation between them, because they are connected, how they are related? Oh, this one has one input stream, this one has an output stream, this one has its own input stream, and this one has its own output stream. Okay, which is available with the help of get input stream, get output stream method. And now here is an output stream, and okay, here also we have an output stream, right? So if someone writes to this output stream, okay, this is what is going to be, this is how it flows. So from this input stream, you can read what was written by the output stream on the other connected socket. Okay, if someone writes on this output stream over here, fine, it flows from here to here, and here it can be read. So this is an input stream from where you can read what is written to the connected socket's output stream. Okay, you write here. So if you write here, fine, your writes over here on this object will be read on the connected socket's input stream. Okay, yeah, so that's how they are connected basically, right? Your write over here, and you can write here. Okay, that's going to be available for read here. Read from this side. Okay, so when you call the constructor of socket, two connected sockets get created. Right? Fine. So when we have two connected sockets, yes, you can use their input stream and output stream in this manner. Okay.
Another one created is for the client side.
This is using the constructor. That's with the help of new. Okay, you only do a new. What he is doing? He is using, this is obtained using the accept method. Okay, see one thing, server socket also has a close method. Socket also has a close method. Input stream, output stream, they are all resources, they all have a close method. Okay, now suppose there is a connection which has been created like this and someone closes the server socket. This connection is unaffected. Calling close by this here is, I have stopped listening. I have released this port for use. Fine, but that connection will still stay. I am not accepting any more connections now on this port. Clear? Closing a socket, it's like closing the input stream and output stream. It's like hanging up. You have a phone. So this is, the communication is always between two phones. Fine. Your server socket is only involved to the extent of giving you a socket object. Okay. It's just making available the socket object. Socket gets created because the client called the constructor. For server, the socket is created because a client has called the constructor. Okay, and you get blocked till that point of time. Fine, unless you have given your timeout setting, in which case, yes, you are throwing an exception. Okay, fine. Now, just like we have a timeout for the server socket, even socket also has a timeout. Fine, there is a timeout setting even on the socket object. What is the timeout? Where is it applicable? Which method will the, so socket also has a method called set so timeout, same method, set so timeout and get so timeout, available also in the socket class. Okay, so where do you have a blocking method in a socket? What is the blocking method of the socket? No, there's no blocking method in the socket, right? Okay. Socket has the method called get input stream, and input stream has a method called read, which is the blocking method. So when you're listening for someone to send something, right, the client may be waiting for the server to send something, and on the other side, because of something, something wrong in the protocol, somewhere they misunderstood both of them. Fine. So both of them are just waiting for the other side to speak. Okay. So both of them are just waiting on the read. Then they'll just keep on waiting, right? It's like that, pehle aap. Okay, fine. So fine, that kind of a scenario can always happen, right? Okay. And for that reason, we have a timeout on the read. So that you can do by set. So the setting is done on the socket object. So socket has the method called set so timeout. So set so timeout, get so timeout, their method even in the socket class. It applies to the read method of the input stream from that socket. Fine, clear? Okay, so fine. So now what can we do? Yes, we can do some coding related to the, fine. I have just shown you the minimum things needed. Okay. Fine. Okay, so fine, let's write some code where we can use a TCP/IP connection. Fine. And yeah, so we want to use a TCP/IP connection like this. So what can be done? We'll be writing the server side. Remember this. Okay, we'll be writing the server side. So on the server side, what should be done? The most simplest form of server, if one can write, will be something like this. We can say, okay, we'll reserve a port, fine. start waiting for a connection, and whenever someone connects, fine, what we will do is on that connection we'll read the data which is received. Okay, so from the input stream we'll receive data, and that same data we'll just put it back to the client. Okay, but before we put back to the client, when we will display it locally on the server. Okay, this is what I have received. Fine, so very simple thing. Okay, fine, we'll just, so whatever you receive, just send it back. So it's a, we can say, oh, this is our echo server, right, which does an echoing. Whatever comes, it just echoes it back. Okay, fine. So a simple exercise would be to use a echo server. But what is applicable to us if we want to use it in our application, what we have already developed, right? How will it be used? Okay, see, in our exercise, how we have to use it is something like this. We have the bank clerk, right? Which is being created with the help of bank. We need a bank. So what we need to do doing is we need to create a bank object first. Okay, so that we can do the way we are doing currently, right? Either from the file or from the constructor. So first object we would be creating is a bank object, right? And then we also reserve a port and start listening. Okay, so start listening, that means you have a server socket object. Okay, have a server socket object, wait for a client to connect through the accept method. Okay, wait for a client to connect. So when client has connected, from this you have obtained a socket object. Okay, and the socket has the input stream and the output stream, which is nothing but connected to the client. And it's a connection to the client. And now our idea is, yes, on this input stream we'll read the command, right, process the command, and whatever output we want to give, we'll put it on this output stream of the socket. Right? Yeah. Yeah, so that it goes to the client. So client, whatever he can send, the client is sending a command, and he should be getting back the responses from us. Server has to do the reading of commands from that input stream of the socket, and getting a socket for the connection from a client, and reading on the input stream of the socket. Fine. So we have parameterized how does this bank clerk is created, right? He can be created with the help of a bank and an input stream and output stream. Look at the constructor we have, and we have made a provision for that. Okay, any input stream, any output stream. See, that input stream is used for creating the scanner object, and then find that output stream was used for creating a print writer, so that we can use the println method to send our responses. Okay, and so clear why we have parameterized that constructor. Fine, we have kept input stream, output stream as a parameter to be able to receive commands from any place. Okay, and especially we had in mind that yes, we would be having a network based connection, and we should be able to read and write on the network. Fine, so we'll carry out both of these exercises. Okay, one will be where we will be using the writing a echo server. Then let's create one echo server, and then for this we'll create a bank server. Okay, so bank server creates a bank, creates a server socket, waits for a client to connect. When a client connects, creates a bank clerk for handling that client. So each time a client connects, I must have a bank clerk who can handle him. Okay, bank clerk is able to handle by taking commands from an input stream and writing the responses to an output stream. Okay, fine, we'll write the echo server first, and then we can switch to the exercise which we were having for the bank, right? So our commands for the bank server. So we will be creating two things, echo server and a bank server. And so both sides, just the next step should be, so if this is what is done, right? Input stream. Okay, you will just say s.get input stream. Okay, and you'll have the output stream equal to s.get. And so given a socket, so this is how the client and server, they both would be having a transmitter and receiver of their own for writing and reading. Okay, and then yes, the receiver dot read method and transmitter dot write method. That's how we will be